We'll explore a tool that is very useful to analyze the different relationship between structures, similar structures. So I have taken a number of volumes from EMDB. They are all SARS-CoV-2 spike proteins in different states and conformations. So if you can see that they have different sizes. So for instance, the different sizes 512. This is 480. Different pixel sizes. This is 0.86. This is 1.36, 256. So the first thing I have done is to put all of them on the same framework, geometrical framework. So this is done homogenizing the pixel size and the box size, so we can see any one of those. So and we can see that okay, so we have the trimer, and we can see from one side, and as always the central region normally is better resolved. The N-terminal domains and the RBDs are worse resolved. We can look at one of them in 3 dimensions. So this is what we have. So we normally represent like this. These are the fuzzy regions where we have fewer details, and yeah, so spikes like this. Okay, so we see that some of them are already coming from the same study, so they have classified into different conformations. So for instance, maybe one up, these are from the 3 RBDs, and then 3 RBDs can be down, or receptor binding domains. So the 3 RBDs can be down, or one of them can be up, or halfway, or whatever. So they have recognized different states. I have taken away all the structures that have extra masses, like antibodies bound, and then yeah, we have to put all of them into the same framework. So the same framework, the same geometrical framework, is not only same box size and same pixel size, but they are also aligned to each other. So you take one of them as input, so you take one of them as input, as reference, and then you align all the others to that one, including the same one. So this 34464 is the same reference and aligned to itself, so that it comes out in the output volumes. So this set of volumes contains all of them. You see that well, they are certainly different, and let's see, this one is even more different than the rest. And let's see what is the relationship between each one of them. So for this, StructMap is very useful. So StructMap, actually, it is a very simple thing. You take a set of volumes, a target resolution, and then you compute the correlation of all versus all, and this will give you kind of distance matrix, and this distance matrix can be mapped onto a lower dimensional space through multidimensional scaling, and then we can see what are the different relationships. So for instance, here we see this that nearby samples. So for instance, 304.64 is close to 465, and 490 is close to 491. So similar studies are close to each other, and then we can put all these studies in perspective. So we can try, we can see kind of trajectory. So it starts here and it goes all the way down to here. Even some studies are intermixed. So for instance, we see here that 97, 99, 98, but then in the middle we get this 27,523. That is a different study, but somehow this structure was similar to this one. And this is a 3D trajectory, and this is the projection in 2D of that trajectory. And we can see, for instance, convolve like this, so that we can see whether they are clustering in some region. So all these maps here, they are kind of similar, and we can now inspect the structure and see, put some order in. So for instance, if we are doing a morphing, we can do the morphing following this order, so that we can try to understand what is the trajectory followed by the particles. So sometimes you get very nice trajectories, like in this case. In some other cases you get a kind of cloud, meaning that what you have is kind of random walk around an equilibrium structure, and then you have all kind of variations. But in this particular example with the spike, there is a very natural movement between the three down RBDs and the one up RBD. So there is a trajectory moving one of the RBDs up and down, and you can put all these structures in perspective with respect to that trajectory. So this would be all for this project, and see you in the next one.